Alright, so today what we're going to look at is how to solve square roots. And we're going to look at, or solve quadratics. And we're going to look at three different methods. A square rooting method, which is the method only works if there's just an x squared term in it. Okay, so if it's got x squared plus 3x or something like that, the square rooting method will not work for the problem. So as kind of a little hint, we're looking at, is there only x squared in the problem. Second method is a factoring method. In order to solve this way, we have to be able to factor, so you have to make sure you watch the factoring video as one of the prerequisite skills, so you know how to do that. The big thing with that is you have to set it equal to 0, and this doesn't always work. It only works if the problem is factorable. Okay, so it's a nice one if it works, but it's not a catch-all. It doesn't work on every single quadratic. And then lastly, we're going to look at a method called completing the square, which is also one of our prerequisite skills for this unit. So make sure you've watched that video and done a little bit of practice on how to complete the square. All right, so we're going to work on 4 examples. I'm going to go through 4 different problems. I'm going to do a couple of them multiple ways to kind of just show you the difference between the methods if they can be solved both ways. So first example I'm going to look at is x squared plus 4 equals negative 5. So we're going to look at x squared plus 4 equals negative 5. As I noticed that all I have in the problem is an x squared. Okay, so there's only one x in the problem, it's being squared, so that means I can do this square rooting method. And the idea of the square rooting method is to simply get the x squared by itself. Okay? Well, I notice on the same side of the equal sign I have x squared and plus 4. Okay, so I want to get rid of this plus 4, so I'm going to subtract 4 first. And that's going to leave me with x squared equals negative 9. Now the idea is I want to get rid of the square. Well, the opposite of squaring something is square rooting. Now, one of the key things you got to be very, very careful about is when you introduce the square root to a problem, you need to put a plus or minus in front of the square root, okay, on the number side. The reason for that is there are 2 different numbers that when you square them get you an answer. Okay, especially if you're looking at, what number squared equals 4. Well, 2 squared is 4, but so is negative 2. Okay, so we got to get both of our answers by using this plus or minus. So be very, very careful about that. All right, the reason why I square root is to cancel out the squaring. So I'm left with x equals, and I get plus or minus the square root of negative 9. Well, again, one of our prerequisite skills was on simplifying square roots. And one of the things you should have learned from that video is you cannot take the square root of a negative 9, at least in the real numbers. What it does is it produces an imaginary number. Okay? So anytime we have a square root of a negative, we rewrite it using imaginary numbers. We rewrite it as I times the square root of that positive. So we end up with plus or minus I times the square root of 9, where the square root of 9 is actually a perfect square. So I can rewrite that as simply the number 3, and then I'm going to put that in front of the variable. So I'm going to switch it up a little bit, or in front of the I. So I get plus or minus 3i. So there's your answer to this problem, both a positive and a negative 3i. Okay. So again, a couple things through this. I saw when I looked at this problem initially, I only see an x squared, so I'm thinking about square rooting. So I want to isolate. If I had a coefficient like a 3 here, I would have subtracted 4 first, then divided by 3, get that square root by itself, and then from there, take the square root, don't forget the plus or minus to get those 2 answers, and then go from there. All right, example 2. We're going to look at x squared minus 5x equals negative 4. So x squared minus 5x equals negative 4. Now I notice I have an x squared and an x. So the square rooting method is out. Okay, so I've got to move on down my list. So the first thing I'm going to do is I'm going to see if I can factor this. I was mentioned in the beginning of the video, in order to factor, you have to get it set equal to 0. So I'm going to add 4 over. So I get x squared minus 5x plus 4 equals 0. Okay, so now my goal is to see if I can factor this. In order to factor it, I have to do my product sum numbers. Again, make sure you watch the factoring video. And it does factor. It factors into x minus 1 and x minus 4. Okay? So again, x minus 1 times x minus 4, if I multiplied it out, negative 1 times negative 4 multiplies to positive 4, and negative 1 plus negative 4 adds to negative 5. Okay? But again, it's a long process. Watch the factoring video. Once I have this, what I have going on here is I have two numbers, or two factors, whose product is 0. Okay? If two numbers multiplied together equals 0, one of the two numbers has to be 0. It's a little property where a times b equals 0. Either a is 0 or b is 0. It's the only way to multiply two numbers together and get 0. One of them has to be 0. Well, a in this case is my factor x minus 1, and b in this problem is my factor x minus 4. So what I'm going to do here, once I factor it, I simply set each factor equal to 0. So I get x minus 1 equals 0, x minus 4 equals 0, and then solve, add 1. So x equals 1 is one answer, add 4, x equals 4 is the other. There are my two answers, x equals 1 or x equals 4. Okay, so again, I noticed square rooting didn't work because I have an x squared and an x term. So I tried factoring, set it equal to 0 first, found my product sum. Again, watch the factoring video to be able to do that. And then set each factor equal to 0. So x minus 1 equal to 0 and x minus 4 equal to 0. And then solve for x. All right, I'm going to talk about how to do this using completing the square as a method, just to kind of show you. Some people will kind of like this method and might want to use it. Okay? When you do completing the square, you don't need to get the equation equal to 0. What I really want is just the x squared term and the x term on one side, and move the number actually to the other, which is already the case here. Okay? So what I'm going to do then is I'm going to try to turn this into a perfect square trinomial. Okay? So again, watch the completing the square video. But in order to do that, I'm going to take half of negative 5, which is negative 5 halves, and square it. So negative 5 halves squared is 25 fourths. Okay, so that's what I'm going to add. I get x squared minus 5x plus 25 fourths. But whatever I do to one side of an equation, I basically added 25 fourths that was not there originally. Whatever I do to one side, I have to do to the other to keep it balanced. So I have negative 4 plus 25 fourths. Over here, this turns into a binomial squared. So this becomes x minus half of b. And over here, in order to add negative 4 and 25 fourths, I need a common denominator, which is going to be 4. So I'm going to multiply top and bottom by 4 of this first fraction. So that's going to be negative 16 fourths, and negative 16 plus 25 is 9. So I get 9 fourths on that right side. All right, now I'm actually kind of back to a square rooting where all I have is something that's being squared. So to get rid of something that's squared, I'm going to square root, putting in my plus or minus. That's going to cancel the square, so I'm going to be left with x minus 5 halves equals. And the square root of 9 fourths can be broken into the square root of 9, which is 3, and the square root of 4, which is 2. So this becomes plus or minus 3 halves. And then all I want to do then is add 5 halves to the other side. And so I get 5 halves plus or minus 3 halves. Well, when I add them together, 5 halves plus 3 halves, 5 plus 3 is 8, over 2 is 4. And when I subtract them, 5 minus 3 is 2, divided by 2 is 1. And sure enough, those are the exact same two answers I got when I factored it. Okay? As you can tell, factoring is probably a little bit quicker and easier and cleaner method for this one. But again, factoring doesn't work all the time. Okay, so two ways to kind of do this same problem. Third example. So look at x squared plus 6x minus 1 equals 5. Again, I've got an x squared and an x term in there, so square rooting is not going to work. So I'm going to either try to factor or complete the square. Again, I think factoring is easier if it's possible. So I'm first going to set this equal to 0. So I minus 5. And so I have x squared plus 6x minus 6 equals 0. Well, if I go through my product sum numbers chart, my product is a times c, so negative 6, and my sum is b, positive 6. So I'm trying to find two numbers that multiply to negative 6 and add to positive 6. Well, to multiply by 6, it's 1 and 6 or 2 and 3. And there's no combo of these when I add or subtract them that gets me to 6. So that means this guy is not factorable. So unfortunately, this method isn't going to work. So that means I'm going to use the completing the square method to do this. In order to complete the square, I want to just have the x squared and the 6x on one side, so I'm going to add 1 over. So I get x squared plus 6x equals 6. Then what I'm going to do is complete the square. So I'm going to take half of 6 and square it. So half of 6 is 3. 3 squared is 9. And again, whatever I do to one side of an equation, I have to do the other to balance it. So I'm going to add 9 over here as well. So this guy is going to then factor into a binomial squared. And again, we find this value by taking half of the b value. So this is going to be plus 3. And over here is 15. Now square root it. Adding in that plus or minus. The square root and the square cancel, leaving me with my x plus 3 equals 15. If I try to break 15 down, 3 and 5, 15, there's no perfect square, there's no pairs, so I have to leave it as the square root of 15. And then my last step to solve for x is to minus 3. I always like to put what I added or subtracted out in front of the plus or minus square root. Just looks a little bit nicer, negative 3 plus or minus the square root of 15. And that's your answer. So two answers, negative 3 plus the square root of 15 and negative 3 minus the square root of 15. Okay. So again, couldn't square root it because of the x squared and the x term. Couldn't factor it because the product and sum didn't work. So I used completing the square to kind of finish off the problem. And I think it's kind of a nice one. It worked out pretty easily for us. All right, so I'm going to do one last example. I'm going to do a problem that's got a coefficient on the x squared in it. So example 4, 5x squared plus 7x equals 6. Okay, so again, x squared and x, so I'm not going to be able to square root it. So I'm going to first try to factor it. So I'm going to set it equal to 0 by bringing the 6 over. Again, I'm going to do like my product sum numbers. Product is negative 30. Sum is 7. 10 and negative 3. So this one is factorable. Okay, so I'm going to factor by splitting the middle term. So I get 5x squared plus 10x minus 3x minus 6 equals 0. Group. Again, if you're not following along on this, watch the factoring video. Pull out a 5x, x plus 2, pull out a negative 3, x plus 2. I did it right because the x plus 2's are the same. So then one parenthesis is x plus 2, and the other is 5x minus 3. Alright, and then what we just learned is once I have it factored, I set each factor equal to 0 to solve. So I get x plus 2 equals 0. Therefore, x equals negative 2 when I subtract 2 to the other side. And then 5x minus 3 equals 0. Add 3. So 5x equals 3. And then divide by 5. So my second answer is x is 3/5. So my two answers, x equals negative 2 and x equals 3/5. So a little bit more work with the factoring, and then setting it equal to 0, just a two-step equation, add the 3 and divide by 5 to get your answer. Okay. All right. Like I said, we're going to do this completing the square as well. I've already got the 6 over to the other side, so that's good. The first thing I want to do is I want to actually pull out the 5. Okay, I want this to be just a 1x squared here. So I'm going to factor out a 5. And when I factor, I'm using division. Okay, so I'm really taking 7 divided by 5. So this is going to be 7/5 x. The next thing I'm going to do is I'm going to divide over this 5 to the other side. I'm going to kind of get rid of it. So I'm going to use division by 5. So I get x squared plus 7/5 x plus something to complete the square equals 6/5. All right. Again, to complete the square, I have to take half of 7/5. So half of 7/5 is 7/10. And 7/10 squared, so 7/10 squared, square the 7 is 49, square the 10 is 100. So this is 49/100. Alright, again remember, whatever I do to one side, I have to do to the other. So since I added 49/100 here, I have to add 49/100 to the other side. Alright, so now over here, I'm going to write it as a perfect square trinomial. So I'm going to take half of the 7/5, which is 7/10, squared, equals. Over here, I have to combine the 6/5 plus the 49/100. So I have to get a common denominator between them, which is going to be 100. I can multiply 5 by 20. 20 times 6 is 120. 120 plus 49 is 169. So this right side becomes 169/100. Alright, now to get rid of the square, I'm going to square root. Putting in that plus or minus. Square root's going to cancel, so I'm left with, don't really need the parentheses here, x plus 7/10 equals plus or minus. Square root of 169 is 13. Square root of 100 is 10. So this is just 13/10. Subtract the 7/10. Alright, so negative 7/10 plus 13/10. Negative 7 plus 13 is 6. 6 divided by 10 reduces to 3/5. And then the second one will be negative 7 minus 13. Negative 7 minus 13 is negative 20. Negative 20 divided by 10 is negative 2. And there are my answers. X equals 3/5 and x equals negative 2. Okay. So again, completing the square, it's going to be, in my opinion, a little bit tougher than the factoring piece, as long as you know how to factor and can do your product sum. But again, the problem is not everything is factorable, so we need kind of another method to to use, and completing the squares is a nice method. Does get some fractions in there, so again, you got to get that common denominator in order to add and subtract fractions.